Spanning tree protocol. You see, this protocol is according to IEEE 802.1b standard. Later, IEEE 802.1w1s also have come, and that we call it as Rapid Spanning Tree Protocol and Multiple VLAN Spanning Tree Protocol, MSTP or MST. People don't say this P here, MST. These things we will be focusing in CCNP, which is going to be starting from Wednesday onwards. Now, this is our CCNA level of spanning tree we are going to see. So what we will do is, we learned that spanning tree protocol prevents loop. We saw that whenever we have redundant paths, we had a topology like this. We had a topology like this with two link, and we saw loops are very easy to occur whenever we have redundant path. Not only in this type of topology, even when you have something like this, loop will occur. For example, this PC here is sending a layer 2 broadcast, example R. Because it's a broadcast, it will go this way and also this way. This switch will flood it via all ports, and it will also come down here like this. This will also flood, and it will go like this, and go like this, and will go like this. Same way, this one which goes like this will go like this, will come back like this, go like. It's going to be a loop. Wherever we have multiple paths, loop will occur. See, the switch 1 can be reached by switch 2 via switch 3 and also straight to switch 1. That is the redundant path. Yeah. So wherever we have redundant paths, even this is another example of redundant paths. This is how in the real world we do cabling, so that even if this link goes down, traffic to B from A can go like this, can go like this, can also go like this if this link goes down, something like that, We got multiple paths so that in no case the packets will get lost. But having multiple paths will also cause loop. Is multiple path important? Yes, it is very important. At the same time, we don't want loop. That's why spanning tree protocol is enabled by default to prevent loop. We no need to block any, shut down any ports manually. Spanning tree protocol will do it when it finds there is a possibility of loop. How spanning tree protocol can find the possibility of occurrence of loop? By sending bridge protocol data unit, which we saw, BPDU. Bridge is nothing but another word for switch. Switch. Earlier, it was called as bridge. So bridge and switch are same. Bridge and switch are same. The other word for bridge is what switch is in present scenario. But in olden days, bridge and switch was not same. even though they both are layer 2 device. Why? We learned in the CCNA introduction classes, the beginning classes, bridges are software based device. Switches are hardware based device. So there is a difference. Definitely there is a difference. But because there is no bridges today, you can interchange this word nothing wrong. Bridges can be used, the word bridge can be used in the place of switch. I heard many people saying bridge in the production. Now, bridge protocol, meaning switch protocol, switches need to run this protocol. Data unit, it's a data link layer device. So it's a unit, a box. Switch is a unit which works in layer 2, and this is a layer 2 protocol, BPDU. It is going to send tiny packets on all port. Inside the packet, what you will find is the switch information about the switch which is sending the BPDU. For example, the BPDU that is coming out from switch 1 will have switch 1's MAC address, switch 1's this port information. In under the port, you will have port priority, port cost, all those information. Yeah. So now when this BPDU comes to switch 2 is supposed to forward it to everyone. And switch 3 now learns about switch 1, and BPD of switch 2 will also come to switch 3. So switch 3 knows that I'm connected to switch 2 and switch 2 is connected to switch 1. And switch 3 sends that BPDU which it received from switch 1, switch 2, switch 3 to switch 1 back. When switch 1 receives its own BPDU coming back on another port, this port is F01, but the BPDU is coming back on which port? F02. Then switch 1 realizes that there is a chance of loop. So to prevent loop, it will go and ask STP, it will provoke the STP protocol, it will initiate the STP process, and STP process will find a blocking spot like this so that loop can be avoided. Now the BPD of switch 1 goes to switch 3 and to switch 2, and switch 2 will not send it to switch 1. Likewise, switch 1 also won't send. But I want to make something very clear here. Listen carefully. BPDUs will be sent and received in this port. You may say, just now you said the BPDU coming from here, it will go here, it won't go here. Yes, I said. That is just to make you understand the blocking port. But the reality is, the truth is, it is the BPDU which made this switch to realize that there is a loop. If that BPDU is blocked, then how the loop can be made, so how the blocking can be maintained? There is a chance of loop is known through the BPDU, which made the switches to block this port. If this block need to continue, the BPD of switch 1 need to go to switch 1 back via other port. Only then this block will be maintained. So I want to change the version of my explanation. Blocking ports are not blocking the management ports like management traffics like BPDU, Blocking ports only block the user traffic. Blocking ports only block the traffic coming from computers, connected devices. Blocking port won't block BPDU. Why? In order to maintain the block, BPDU is important. So, what you need to understand from this, blocking is not literally shutting down the port. Blocking is the software on the switch prevents user traffic in passing through the port. Preventing the user traffic passing through the port. That is what the blocking port does. Blocking port is not blocking BPDU. This may be a very sensitive evaluating question in interview. Will the blocking port allow the BPDU to pass through? Yes or no? Your answer need to be yes. It will allow to pass through. So blocking port is not shut down. See, if you shut down a port, no BPDUs can go, nothing can go. But this is software blocking because of STP's instruction. STP instructs that there is a loop, chances of loop, so you're not supposed to allow any traffic to pass through. Okay, so now what we are going to learn next is how this blocking spot is picked. How the blocking spot is picked. Right. You see, we got two wires, switch 1, switch 2. To select a port to be a blocking port, there is some steps the switches will undergo. First, between these two switches, one switch will be elected as a root switch. Root switch. Between these two switches, one switch will be elected as a root switch. What does that mean by root switch? The switch whose ports will not be blocking. A root switch port, the ports of the root switch will not block. For example, if this is the root switch, this port and this port will only forward. They are not supposed to block. See, out of 4 ports, already 2 ports, you know they won't block. So blocking may occur here or here. Fine. So to decide which port to block among these 4 ports, very first step the switches have to do is elect one of the switch as a root switch. Root. This root. Root switch. Root switch. That root. Root means that's the place where water is taken and necessary food. Even though photosynthesis happens on the top using the green pigment called chlorophyll, which is in the leaf, but for that food to be cooked, water is needed, and more strength from the soil is needed for the plant. So root is very important. If root is cut off, no use of that leaf and food factory. Plant cannot grow, die. So root cannot be cut off. That is why it is forwarding. See how meaningfully they named it. You cannot have a block in the root. That's a root switch. It will always forward the water for all the branches. See, you understand why they named it as root switch? The port that won't block, it will only forward because it's a root switch, important switch, center of attraction, point of reference switch. It's a root switch. Okay, so we got the root switch. So you can now 50-50. Already 50% among this 4 port, 2 ports are forwarding. So we now know the blocking will be happening on any one of the port in the second switch, switch 2. Fine. First of all, let us understand how a root switch is elected. Not randomly one of the switch will be elected as a root switch. No random business. There should be some proper steps, criteria. What happens is, between these two switches, they are going to send a BPDU, you know that. Through the BPDUs, one switch will know about the other switch's priority and the MAC address. I repeat. Bridge Protocol Data Unit, BPDU. This BPDU is sending the switch MAC address, the switch priority, the port from where the packet is coming out, what is the port priority, port call, all information. So what the switches will do, they compare their priority. They compare their priority, and the one with the small priority is the winner. Small priority switch will be the root switch. Small priority switch will be a root switch. What is the priority? It's a numerical number, which is 32768 by default on all switch. This is a number called priority, which is there by default 32768. If you will configure one of the switch priority lesser than this default, for example, I go inside the switch and I configure the priority as 0. Then this is the root switch. This is eligible candidate to be a root. It is based on the priority. And the priority with a small number is a winner. That is also very important to understand. The priority should be small than the other switch. But I told you the default priority is 32768 and we did not change it. You see, in the previous class, we saw the blocking port automatically elected by STP. I did not set any priority. I did not say this is the root switch. I didn't do any configuration. And you saw a blocking port. How that happened? Whenever the priority is a tie, it will check the MAC address. Again, the switch with a small MAC address is a winner. Will any MAC address same with other switch? No. No two devices will have same MAC address. No two devices will have same MAC address. So if the priority first, it checks. If the priority is a tie, then it checks the MAC address. Definitely there will be one MAC address lower than the other switch's MAC address. Let's say, for example, the MAC address of this is 1ABC. The MAC address of this is 2XYZ. We know that this is a small MAC address. So this switch is the root switch. If this is the root switch, these ports will forward. They will not block. They are called as designated ports, and they will forward. Designated ports will always forward because they are designated to forward. Now this switch, the second switch, this switch knows that the other switch has become a root switch. Switch 2 knows that switch 1 has already become a root switch. Fine. If that is the root switch, which path is the best path to reach the root switch? Which path is the best? Is this the one best or is this the one best? Which one is the best path? I'll keep the best and I'll block the worst. If this is the best path, then I'll block this one. But how it decides which is best? It will compare the link STP cost. If it is 100 meg, the cost is 19. If it is 10 meg, the cost is 100. If it is 1000 meg, which can also be called as 1 gig, the cost is 4. If it is 10 gig, the cost is 2. Don't ask me how you got this number. These numbers are predefined as per the standard. There is a calculation involved behind, but it's not necessary. You should know that 1 gig is 2. Sorry, 1 gig is 4. 100 meg is 19. This fast Ethernets are 100 meg. This fast Ethernet So that is forwarding. This is fast Ethernet. Fast Ethernets are 100 meg wire. 100 meg cost is 19. Now, there is a tie. See, it is trying to choose the best path, but the problem is both the paths have got same cost. If in case this is 1000 meg, then cost is here 4, this would have blocked. This port would have gone blocking. But in our case, both the links are 100 meg. So there is a tie. Couldn't decide. What is the cost on 100 meg? 19. Based on the cost, switch 2 can't decide. So now what switch 2 will do? It will compare the, listen to me carefully, it will compare the incoming port cost. Here, for this port, what is the cost coming? 128.24. Port number 24 will have dot 24. This 128 is same for all ports. And for this port, it is 128.5. So this incoming, let's say this port is here 1/32, 1/10. Listen to me carefully. This port cost is 128.32. This port cost is 128.10. It will not consider this. Switch 2 won't consider local cost. It will consider incoming. Which one is lower? On which port you are getting the incoming lower? F132 or F110? In which port you are getting incoming lower? Answer. In switch 2, on which port the incoming you are receiving lower? Are you receiving in 132 or 1/10? நீங்க நல்லா கவனிச்சு சொல்லுங்க. எதுல இன்கமிங் கம்மியா வருது? 32க்குள்ள வர்றது கம்மியா வருதா? கம்மிங்னு சொன்ன மேல இருந்து வர்றது சொன்ன. Which is 128.5 is lower than 128.24. Which is lower? 5 or 24? 5 is lower. So in this port only the incoming is lower or smaller. See, from the beginning, if you notice, small is what spanning tree prefers. So spanning tree will prefer this port and block this port. Yeah, it prefers the port which receives, not local cost, receives the incoming port cost lower. Ma'am, did you understand that? Right. மேல இருந்து வர்றதுதான் இந்த கீழே இருக்கிற சுவிட்ச் பார்க்கும்போது தன்னுடைய சொந்த காஸ்ட்டை தான் பார்க்காது. சொந்த காஸ்ட்டை பார்த்துச்சுன்னா இதுதான் லோவர், இதுதான் ஃபார்வர்ட் பண்ணணும் நியாயமா. ஆனா நான் சொல்றேன் அப்படி பார்க்கறது. மேல இருந்து என்ன வருது அதை கம்பேர் பண்ணு. In one of the port I am receiving 128.5. In another port I am receiving 128.24. I prefer the port which receives 128.5. So now this port is called as root port. What does that mean? This is the port that connects to the root switch. That is why this port is called as root port. See, this is not on the root switch. On the root switch, ports are not named as root port. On the root switch, ports are named as designated port. Whereas on the other switches that connects to the root, you will find a root port. The port that is operational. The port that is not blocking. The port that is talking to the root switch is the root port. So root port definitely it has to forward because it is talking to the root. See how big truth you can see here. The truth is this is blocking, this is the root, which means this branch, if it needs water, it needs to connect to the root. So definitely it's a part of root. It's a part of root switch. That's why they named it as root port. Root port. கிளையானது மரத்தில் சாராவிட்டால் இந்த கிளை உயிர் வாழ முடியாது, மரித்துவிடும், இறந்துவிடும், செத்து போயிடும். The branches have to abide on the stem. So the branch becomes a part of stem and stem becomes part of root. See how nicely they named it as a root port. The port on the switch which talks to the root switch is a root port. And what is this port called as? Blocking port. I showed you these things in the previous class. BLK and ALT means what? Alternate. In case if something goes wrong with this will be unblocked and this will forward. Right? Fine. So go through this video once and